Okay, so this recording is going to be the additional practice problems for chapter 12 in chemistry. So number one is just a series of compounds that you are to give the oxidation state for each atom. So the first one is this. Okay, so looking at the oxidation rules that can be found on page 360 in your book, we know that the oxidation state for hydrogen is always +1. We know that the oxidation state of oxygen is usually -2. And we also know that because there's no charge on this molecule, that the total charges have to add up to 0. So we have -6 here on the oxygen. We have +1 on the hydrogen. So in order for this molecule to add up to 0, the charge on the chlorine has to be +5. Okay, so that's 1A. 1B is P2. Okay, so this is a homonuclear molecule, and rule number 2 tells us that the oxidation state for homonuclear molecules is always 0. Okay, C is this. So sodium, this is an ionic molecule, and it says for ions, the oxidation state is equal to the charge of the ion. So sodium's charge, sodium is in column 1A, so its charge is +1. And there's 2 of those, so the charge on the sodium would be +2, and therefore the sulfur needs to be a -2 in order for the whole molecule to have a charge of 0. Okay, letter D is SO4, and then the whole molecule has a charge of -2. Okay, so when we look at our rules, we don't have a rule for sulfur, but we do have a rule that is usually true for oxygen, and that is that it's -2. Okay, so that's -8. And the whole molecule has to have a charge of -2. So that would mean that the sulfur would have a charge of +6, because +6 minus and a -8 is going to give you that overall charge of a -2. Okay, 1E is calcium. Okay, so this is ionic, so the calcium is in column 2A, so it's going to have a charge of +2. We don't really have a rule that applies to carbon, but we know that oxygen usually is -2, so that gives us -6 and +2, and the charge of the whole molecule has to be 0, therefore the carbon must be +4. Okay, so we get the -6 here, and then +2 here, so the carbon is a +4. One F is FBr. Okay, so we know from Rule 4, that the oxidation state of fluorine is always -1. And there's no charge on this molecule, so it's the sum has to equal 0. And so the bromine must be +1. Okay, letter G is KNO2. Okay, so potassium is an ion, and it's in column 1. So that's going to give us a charge of +1. We don't have a rule for nitrogen, but we know that oxygen is usually -2. So -2, and there's 2 of those, so that's going to be -4, and the potassium is +1. The charge on this whole molecule is 0, and therefore the nitrogen has to be +3. Okay, so +1, +3, and then this gives us a -4, so that the total charge is equal to 0. And then the last one is letter H, and for that we're given this. Okay, so rule number 5 tells us that hydrogen has an oxidation state of +1. There's 2 of those, so that gives us +2, and therefore the sulfur has to be -2 because there's no charge on the molecule. So +2 and -2 will give us the overall charge of 0 on that molecule. Okay, number 2 is a series of reactions, and you're asked to indicate whether it's a redox reaction, and also to say what's being oxidized, what's being reduced, and to indicate the oxidizing agent and the reducing agent. Okay, so 2A, the reaction is this. Okay, so start looking at the oxidation states. So strontium, that's just an element, so its oxidation state is 0. Oxygen is a homonuclear molecule, it's a homonuclear diatomic, so its charge is 0. And then if we look at this, this is an ionic compound. Strontium is in column 2. Well, we know that oxygen is usually -2, and also strontium is in column 2A. So strontium has a charge of +2, oxygen -2. So then we look at what happened. The strontium went from 0 to +2. So it lost electrons, and lost electrons means that the strontium was oxidized, LEO, and then the oxygen went from 0 to -2, so it gained electrons, and gained electrons means that it was reduced, GER. So it is a redox reaction, and the strontium was oxidized, the oxygen was reduced. Because the strontium was oxidized, the strontium is the reducing agent. So it lost electrons, but it gave them, it allowed the oxygen to be reduced, therefore it's called a reducing agent. And the oxygen, the O2, gained the electrons, it was reduced, and therefore it was the oxidizing agent. So it gained electrons, meaning that it took those electrons from strontium and allowed strontium to be oxidized. Okay, so that's 2A. 2B, is this. We have carbon plus H2SO4 plus CO2. Oh no, I'm sorry. Gives those are the reactants. The products are CO2 plus 2SO2 and 2 waters. And this was not on there was a mistake on that sheet. So in order for this equation to be balanced in terms of atoms, we need 2 of the H2SO4s. So now it's balanced. You can do it. You could have done it the other way and it wouldn't have affected the outcome, but just so that you know that this is now balanced. Okay, so carbon is an element, so its charge is 0. Hydrogens we know are +1. Oxygens are -2. So we have +2 here, and we have -8 there. So the sulfur has to have a charge of +6, so that the charge on the whole molecule is 0. Okay, we know that oxygen most of the time is -2, so that's 2 times -2 gives us -4, and so the carbon has to be a +4. Again, oxygen is -2, and that gives us -4, so then the sulfur has to be +4 because there's no charge on the whole molecule. We know that hydrogens are always +1, so that's 1 + 1 times 2 is +2, and so the oxygen is -2. Okay, so then we look at each of them. We look at carbon, hydrogen, sulfur, and oxygen. So the carbon went from 0 to +4. So that means that it lost electrons. And lost electrons is oxidized. The hydrogens went from +1 and stayed +1 over here. So nothing happened to the hydrogen. The sulfur went from +6 to +4. So the sulfur gained electrons. So that means that it was reduced. And then the oxygen stayed at -2. So it was -2 on the reactant side, and it's -2 here and here and here on the product side. Okay, so but it is a redox reaction. We had something oxidized and something reduced. So then what is the reducing agent? So carbon is the reducing agent. And then the sulfur gained the electrons, and that sulfur was part of this compound. So the oxidizing agent, so H2SO4, is the oxidizing agent. Okay, so that is 2B. Okay, 2C is this. Okay, so we start by looking at the oxidation state of each atom. The hydrogens are +1. The oxygens are -2, so -6 here over here. +1, the whole molecule has a charge of 0, so that means the nitrogen has to be +5. Hydrogen is +1, so therefore the iodine has to be -1. Oxygen is -2, so the nitrogen has to also be -2 because there's no charge. This is a homonuclear molecule, so it's that charge is 0. And then the hydrogens are +1, there's 2 of them, and so the oxygen is -2. Okay, so then again, we look to see what happened. The hydrogens, the nitrogens, the oxygens, and the iodine. So hydrogen went from +1 on the reactant side and it stayed +1 on the product side. The nitrogen went from +5 to a +2. The oxygen was -2 on the reactant side. It remained -2 on the product side. And the iodine went from -1 to 0. Okay, so the nitrogen and the iodine changed. So the nitrogen went from +5 to +2. So that means that it gained electrons. So if it gained electrons, it was reduced. And the iodine went from -1 to 0, which means that it lost electrons. It lost 1 electron. And when you lose electron, that means it was oxidized. Okay, so then we look, what is the oxidizing agent? So the nitrogen that was reduced came from this. So the oxidizing agent is HNO3. And then the iodine was oxidized, so the reducing agent, that iodine came from here, so the reducing agent is the HI. Okay, so that is 2C. Okay, 2D, we have this. Okay, so again, we just start by looking for oxidation states of each of the atoms. So this is the first one is an ionic compound, so the potassium will have a positive charge of +1 because it's in column 1A. The whole molecule has a charge of 0, so that means bromine is -1. This also is the next one is also an ionic compound. Magnesium is in column 2, so it's going to have a charge of +2. We don't have a rule for nitrogen, but we know that oxygen is -2. So here we have -2 times 3, that's -6, and there's 2 of those, so that's -12. And then we have a +2 here. The whole thing has to equal 0, so that means we need 10 more positive charges. So there's 2 nitrogens, so that means each one is a +5. Okay, so we have 2, this is +2, this times this gives us a +10. Okay, so, and then a -12 because we have a -2 times 3, but there's 2 of those. So that's a -12. So that total adds up to 0. Magnesium bromine. So magnesium again is a +2. And then bromine, that means bromine has to be -1. Not writing on there very well. And then over here we know the potassium is in column 1, so it's +1. We know that oxygen is -2, so we have -6 +1. The charge on the whole thing needs to be 0, so the nitrogen must be +5. Okay, so then we look at what happened to each of the elements. So the potassium was +1 on the reactant side, and it's +1 over there. The bromine was -1 and -1. Magnesium is +2 and +2. Nitrogen is +5. And its oxidation state over here is also +5. And oxygen, its oxidation state here is -2. And its oxidation state over here is also -2. So this is not a redox reaction. Nothing was, in order for it to be a redox reaction, something has to be reduced and something else has to be oxidized. Okay, 2E. Okay, so Sb is an element. It's antimony, and it's because it's an element, its charge is 0. Then over here we know hydrogen is +1. We don't have a rule for nitrogen, so since oxygen is usually -2, so we have -6 and +1. The charge on the whole molecule is 0. So that means that the nitrogen needs to be +5. The SbO2, so Sb is, I guess I should look and see what column that's in. Sb is number 51. Okay, so we don't really have a rule that applies to that. So that means we can go to the oxygen, which is we know is usually -2. So that's -6, and the charge on the whole molecule needs to be 0. So that means this would be +3. Okay, we don't have a rule for nitrogen, but we know that oxygen is -2 usually, and so that nitrogen needs to be +2. We know hydrogen is +1, and oxygen, that would make the oxygen -2, which we know it usually is anyway. Okay, so if you look at the antimony, it went from 0 to +3. The hydrogen went from +1, and it was +1 on the product side. The nitrogen went from +5 to +2, and the oxygen went from -2 and stayed -2. Every place we see it, it's -2. Okay, so the Sb, to go from 0 to +3, it lost electrons. So it was oxidized, and therefore, And then hydrogen and the nitrogen went from +5 to +2. So it gained electrons. So it was reduced. Okay, so the SB was oxidized, but what allowed it to be oxidized was this. So it was oxidized, so it is the reducing agent. So SB is the reducing agent. And then the nitrogen was reduced. It came from this, so therefore the HNO3 is the oxidizing agent. So in other words, SB could give away its electrons because this compound accepted them. So HNO3 is the oxidizing agent. Okay, so that is it for number 2. Number 3 in this question tells us that one side of a galvanic cell has copper, which is a solid, and that copper becomes Cu2+. Okay, so then here's our questions. Is this the anode or the cathode of the cell? Okay, so in order to go from copper to copper +2, that means that it lost electrons. And you should remember that the anode of a battery is what gives up its electrons. So this tells us since it's losing electrons, that tells us that the copper is the anode. Are the electrons flowing toward the electrode or away from the electrode? When those electrons are given up, they're going to flow away from the copper, away from that electrode and through the wire to the other electrode. So they are flowing away from the electrode as they do on the anode. In the salt bridge, are positive or negative ions flowing toward that side of the cell? Well, as that side of the cell gives away more and more electrons, it's going to become positively charged. It's going to become more and more positive. So in order to prevent it from becoming more and more positive, negative charges would flow from the salt bridge to the anode. Okay, then number 4 is two galvanic cells, and you're asked to draw the cell, identify the anode and cathode, the electron flow, and the substances on each side. Okay, so the first one is this. So again, the first thing you want to do is you need to know what is giving up electrons so that you can know what is the anode side and what is the cathode side. So we have to look at the oxidation state. Okay, so aluminum is an element, so it's 0. This tells us that the Pb is +2. And the aluminum here is +3. And then this Pb, it's an element, so it's going to be 0. So the aluminum went from 0 to +3. So in order to do that, it had to lose electrons. And we know that the anode is what loses or gives up its electrons. So that means the aluminum would be the anode. And the Pb, which is lead, went from +2 to 0. So it had to gain electrons to do that. And so the electrons are going to flow from the anode to the cathode. So the lead will be the cathode. Okay, so then it's just a matter of drawing your containers. So the solid, so this is the anode and it's solid. So the electron, the word am I looking for? The electrode. So this electrode would be solid aluminum, and then the one on the cathode side would be the solid lead. Okay, so this is going to be the solid lead. And then these other solutions are aqueous, so there's the substance is dissolved in water. So in this case, we would have the Al +3 in solution, and over here we would have the Pb +2 in solution. And then the electrons are going to flow through the wire. So they're going to flow this way. They're going to leave the anode and go to the cathode. So this is the anode. This is the cathode. And then you just need to draw your salt bridge. Okay, so the salt bridge will be like that so that the charges can be replenished as electrons leave the anode and go to the cathode. Okay, so that's number 4A. 4B gives us this. Okay, so then start by looking at the oxidation state. So this is a homonuclear molecule, so that's 0. This is just an element, so that's 0. This tells us the charge is -1, and this tells us it's +2. Okay, so the iodine went from 0 to -1, so it gained electrons. The calcium went from 0 to +2, and so that means that it lost electrons. So that means this is going to be the anode. And the iodine will be on the cathode side. So this one's a little bit different than the previous problem because the only solid we have is the calcium. So for the electrodes, on the anode side, since it lost the electrons, the electrode would be calcium. Over here, the electrode can be anything. And then we still, so since this is the calcium side, this calcium +2 would be in solution. And any of the iodine forms that are aqueous would be in solution over here. So you'd have I2 over here, and you'd have the I- over here in solution. And then the electrons are going to leave here, and they're going to flow through the wire and into the cathode. So this is the anode. This is the cathode. And those electrons are going to flow in this direction. And then just throw your salt bridge in there, like that. Okay, so that is number 4B. Okay, number 5 says balance the following redox reactions. Okay, so it's cobalt and cesium, or cerium. Okay, so again, we're gonna look. So right now, this equation is balanced with respect to atoms: one cobalt, one cerium, one cerium. But over here we have the total charge is +5, and over here, since this is 0, the total charge over here on this side is +4. So we need to balance the charges. So let's look at the cobalt first. So it went from +2 to 0. So that means that it lost 2 electrons. And the cesium went from +3 to +4. So that means that I'm sorry, I'm messed up here. This means the cobalt gained 2 electrons, gained more negative, so it gained 2 electrons. This lost 1 electron. Okay, so the cobalt is gained 2 electrons. And the only way it could gain 2 electrons is they had to come from 2 cesiums. So we put a 2 there, and then in order to balance it now by atoms, we'd need a 2 there. So now if we look at the charges, we have 2 times 3, which is +6, and we have a +2, so the total over here is +8. And then over here we have a 0, and then we have 2 times 4, so the total charge over there is also +8. So now written like this, this is 2 plus. Now that equation is balanced for atoms, and it's also balanced with respect to charges. The charge on each side is +8. Okay, then the last one is 5B, and for that one we have lead plus gold, and the gold has a 3 positive charge, and that's going to give us gold plus lead with a 2 positive charge. Okay, so again, right now it's balanced for atoms, but it's not balanced for charges, because the lead is 0 and this is +3. So there's a +3 charge there. This is an element, so its charge is 0 and it's +2 over there. So it's not balanced with regard to charges. So the lead went from 0 to +2. So in order to do that, it had to lose 2 electrons. and the gold went from +3 to +2. So that meant that it had to gain 1 electron. Okay, so in order for lead to lose 2 electrons, the gold had to accept those 2 electrons. So that we would take 2 of those. And if now it's not balanced with respect to atoms. So if we put 2 golds over here, now if we look at the charges, 2 times +3, so now this charge is +6. And wait, what did I do there? Start over on this one. I'm not sure where I made a mistake on that. Maybe I copied it wrong. So that one was PB plus AU plus 3 is going to become AU plus PB 2 plus. Okay, so the lead went, this is 0 because it's an element, so lead went from 0 to +2. So it lost 2 electrons. The gold went from +3 to 0. So it gained 3 electrons. Okay, so here for this one we have to look then at the least common multiple, which is 6. Okay, so we can't, there's no way we can change the charge on these because they're just elements. So we have to get a charge of 6 on each side. So to do that, if we have 2 of the golds, that gives that +6 on that side. If we have 3 of those, that gives us +6 on this side. Now we have to balance it with respect to atoms. So there's 2 golds over here, so we need 2 there. There's 3 leads here, so we have to have 3 there. So let me rewrite that. So it'd be 3 PB plus 2 AU with a charge of +3, and that's going to give us 2 AUs plus 3 PBs with a +2 charge. Okay, so now we have 3 leads on each side, 3 PBs on each side, 2 golds on each side. This has a charge of 0, so this is +6. This has a charge of 0, and 3 times +2 is also +6. So now the equation is balanced with respect to atoms and also balanced with respect to charges. Okay, so that's it for the extra practice problems for chapter 12.